a student of Bachelor degree of Manufacturing Engineering. So I would like to express gratitude to my panels, Prof. Madya Dr. Annisya bin Abdurrahman as panel 1, Prof. Madya Lipedrin as panel 2, and Sir Muhammad Faris bin Dimin as panel 3. So first and foremost, my title is Real-Time Breast Cancer Diagnosis System Embedding Deep Learning, and this project is under supervision of Prof. IRTS Dr. Sivarao. Introduction. So cancer is a major public health problem that affects the entire world and is the second leading cause of death in Malaysia. Early detection is vital when it comes to the cancer disease. The tumor size and how far it has spread are the main factors that decide a patient's outcome. Furthermore, scientists also apply variations of methods as early stage screening methods which they can contribute to the detection of cancer before the cause of the symptom. They also have grown new methodologies for the early forecast of malignancy treatment result. With the coming of new advances in the field of medications, measures of malign growth information have been accumulated, and in any case, the exactness of forecast of an infection result is one of generally interesting and trying for doctor who needs to locate the most ideal apparatus for clinical exploration process. Thus, this machine learning strategies have become a mainstream instrument for clinical analysis. And then the utilization of artificial intelligence and information mining strategies has changed the entire procedure of both malign growth diagnosis and prognosis. We conduct this project mainly due to the increases in the number of cases and low survival rate for the late detections, and then the diagnoses are only based on the pathologist's expertise and lack of advanced technology. It's very time consuming, very fatiguing, and every cells need to be examined, and inconsistency. Sometimes cancer is very difficult to recognize. The objective of this project is there are three. And the first one is conduct preliminary investigations on data and modeling suitability for breast cancer detections. Second is develop and optimize CNN model to detecting breast cancer symptom. And the third one is to validate the developed model for 95% breast cancer prediction accuracy. Of the scope, we are going to explore on how the diagnosis of the breast cancer can be predicted using a trained convolutional neural network model based on sample from the PD laboratory of the Brazil. This prediction system is to act as assistance for the pathologist by using supervised algorithm. The key are the predictions of the diagnosis of breast cancer on the basis of the data classification and regression. So what I can conclude from the previous study, the diagnosis of breast cancer only using the digital or digital histopathology images is a watershed moment in the field of the medical pathology. The use of the convolutional neural network in many medical diseases and not only breast cancer to expand our perspective into different possibilities to build the model that will improve significantly and contribute to breast cancer patient itself. Deep learning is a subset of AI designed to identify patterns, uses algorithm and data to give automated insight to the pathologist. It allows for a multitude of benefits including automating tasks and analyzing big patient data set to deliver better diagnosis faster and at a lower cost. At a very basic level, deep learning is a machine learning technique. It teaches a computer to filter inputs through layers to learn how to predict and classify information. The observation can be in terms of images, text, or sound. And then is CNN. So convolutional neural network is a special type of neural network that roughly imitates human vision. It most commonly applied to analyze visual imagery. It uses a special technique called convolutions. CNN are composed of multiple layers of artificial neurons. Artificial neuron is a rough imitation of their biological counterparts and are mathematical functions that calculate the weighted sum of multiple inputs and outputs and activation value. This is the flowchart for this project. So we have three stages which consist of preliminary stage, design stage, and also the results. So we start with the preliminary investigations. where we define the problem statement for this research, the objective, and the scope of this project. After that, we will propose the solution for the problem we define, which is in this case by utilizing deep learning neural network. There are 3 sections which will be resulting to in details process, where we need to define all these prerequisites before we further to design stage. So the 3 sections we need to find out first is the data set that we wanted to use, the dimension of it. Other is we need to know what kind of neural network we wanted to use, whether it's regressions or classifications, CNN or ANN. After we get all of this info, we can design the CNN architecture by deploying it. And then we can calculate all the data and split it into test and train. And we mostly use Keras library for this project. We can then do optimization and validation process to see whether this can analyze the result and make some discussion after we have running the problem. In developing these projects, the main thing and the prior thing is a data set. In this project, a public data set called Breakfast was utilized. Breakfast is divided into 4 magnifications level, which is times by 40, times by hundreds, times by 200, and times by 400. And each picture is identified by its primary category, either malign or malign, and there are only 8 subcategories. This dataset is made up of 7,909 histological biopsy pictures collected from 82 people. PND laboratory in Brazil took these images under the microscope between January and December 2014, with 2,480 benign and 5,429 malign tumor pictures. For model development, we plan to use the DenseNet 201 as a pre-trained array, which already trained from the ImageNet competitions. The dense connected convolutional network was imported from the Keras library application, as it is a network design in which each layer is fed forwardly linked to every other layer, which is dense block. Then the code runs with the DenseNet basic architecture, which has 1x1 convolutional bottleneck layer and compress the number of channels at each transition layer by 0.5. Then the DenseNet 201 networks contains L plus 1 over 2, which is a direct connections, and then we use Adam for the optimizer and binary cross entropy as the loss functions. The data augmentations, image data generator, global average pooling, 50% drops to reduce overfitting. And then we have the batch normalizations, dense layer with 2 neurons with softmax. And the last one is the full model validation. There are 3 ways, which are train and test, confusion matrix, and the performance matrices. Lastly, there's a few limitations in this FYP. So first is the GPU. The GPU is just the heart of the deep learning applications, and the improvement in processing speed is just too huge to ignore. And then we have the problem with the RAM size, because the RAM size, it might hinder from executing our GPU code comfortably without swapping to disk. In this case, we should have enough RAM to comfortably work with our GPU. This means if we have at least the amount of RAM that matches our biggest GPU. And last one is the dataset. Data collected from the foreign patient by the PND laboratory in Brazil. In the case of the breast cancer, there are additional potential factors to consider, including the family health, background, genetic, and lifestyle. If possible, we have the data set from the Malaysian patients. They will be more relatable and will help to strengthen the project hypothesis. And that's all from me. Thank you. Love of my life.